Hi everyone, welcome to part 3 of the Functions Test and Study Guide review. We are talking about graphing functions. So we've talked about transformations in an equation. Now we're talking about how that translates graphically. So what I'd like you to note here is that the parent function for 21 was 1 over x. This function got moved to the right 4, down 1, and then got stretched by a factor of 3. So you'll notice that there is a vertical asymptote where x equals 4, which is why the function is undefined right here, where the function is undefined at x equals 4. That corresponds, of course, because it moved to the right 4 originally, where it was undefined at x equals 0. Right? If I move it in any direction, that ends up being where the new asymptote is. So it's no coincidence that the function's undefined at 4 because I moved the original, the reciprocal function, the parent function, from being undefined at 0 to now being undefined at 4. Now it's also moved down 1, so correspondingly, where the y value used to be, where the function used to be have a restricted range at y equals 0, now because I've moved it down 1, now the range is restricted so that y could be all real numbers except y can't equal -1. I figured out the x-intercept on this, though we didn't talk much about this. I figured out the x-intercept by plugging in 0 for y. And when I set this function equal to 0, I get that x equals 7 makes it equal to 0. Okay? That's just an anchor point on the x-intercept. That would be right out here. Okay, the y-intercept is where x equals 0. So x equals 0, plug 0 in for x, and what we get is -1.75. That is that point right there. We didn't talk as much about those, but I wanted to make sure that you had an explanation. Are there any extreme points, any maximums or minimums? No, none. Is this function ever increasing? No, it is never increasing. It is, the y values are always getting smaller, which is why the interval that it's decreasing over is from -infinity to 0. To 4. That's where the asymptote is. The break is at 4, and then it's continuing to decrease from 4 to infinity as the x values get bigger. All right, so we didn't talk much about end behavior, but the word for this is as x approaches. So as x approaches infinity, the function approaches. That's what those arrows mean. -1. It's really just a way of saying that the function has that asymptote where at a horizontal asymptote where y equals -1, wherever the range restriction is. Okay, now the end behavior is that as x approaches -infinity, so as I go out to the left on this function, what do the y values do? They also approach -1. So as x gets bigger in the positive and x gets bigger in the negative, more positive and more negative, the function, the tail ends, are approaching that y value of -1. All right, in the next one, now I'm looking at a parabola, right, that's been vertically stretched by a factor of 2. It's been moved to the right 3 units, and it's gone down 4 units. So the new vertex should be at the point 3, -4. Well, look at that. Look at where the extrema is. It's an absolute minimum at that new HK point, 3, -4. All right, the domain is all real numbers. The range is all y values greater than -4 because, as we just discussed, that's the lowest point. The x-intercept and the y-intercept I'm less interested in here. We didn't talk much about that. We'll talk about that in the next unit. The function is increasing for all numbers that are greater than, so for all x's that are greater than 3, and it is decreasing for all x's that are less than 3. Again, and behavior that as x gets bigger, y also gets bigger. So as x approaches infinity, y approaches infinity. As x approaches -infinity, so as I go out to the left, the function gets bigger. F of x approaches positive infinity. All right. In the next one, I've got a cube root function. Though we didn't talk about this function, we can talk about the transformations in the domain and the range right now. So transformations that happen is that it moves to the left, to the left 4. It moves up 3, and then it's a vertical stretch by a factor of 2. Okay, the domain for this function is all real numbers. It just continues going left and right, and it just continues. It has outputs for all y's. Okay, there's no discontinuity in here anywhere. The function is always increasing. I'm not worried about the y-intercept and the x-intercept. The end behavior is that as x approaches infinity, so as I go out to the right, the function approaches positive infinity, the y values get bigger, and as x approaches negative infinity, the y values get smaller. So this has opposite end behavior. All right, for part 4, we will talk about piecewise functions. See you in the next video.